talk to you about dilutions. Now, here's what I want to tell you about dilution problems. First of all, the math is not hard. The math is not why students would lose points on these. The only thing that makes the dilution problems hard is understanding what's going on. So I'm going to take some time now to talk about exactly what's going on when you're diluting solutions. First of all, we've talked about exactly what concentrated means and diluted means. Diluted means less solute per solvent, so a lot more water, okay, typically, whereas concentrated means a lot of solute per solvent, okay, so that would be a lot of the solute with less of the water, okay? Now, when we dilute something, this means adding more solvent, and usually that's water, okay? In this class, we're only going to be dealing with water, so it means adding more water to something to make it more dilute, okay? This is actually something we do quite often, okay? An example would be, my husband really loves having Hawaiian punch, but doesn't like it as concentrated as it comes. So he always pours half of it into the glass, and you know what he fills the rest up with? Water. And that means when he's drinking it, it's not going to be as strong, okay? It's going to be less pungent. He likes it that way better, and it actually makes it a little healthier because you're drinking more, but you're not adding more sugar, okay? So let's look at this example here. Here's our first solution. It has a concentration of 12 molar. That means that there are 12 moles of solute per 1 liter of water, okay? So that's pretty concentrated. Now, as we go here, we are adding water. So now that there's more water, a higher volume, do you see how the concentration went down? Because we increased the volume without adding moles. So do you see the difference here? The only difference between these two is we added water. So the number of moles of solute here actually equals the number of moles of solute here. Why? Because we didn't add or take away any solute. All we did was add the solvent, okay? So if we do a little bit of math, we can see that molarity, okay, is moles per liter. And moles, therefore, if we do a little bit of algebra, we can see that moles equals molarity times volume. So if we multiply both sides by volume, that's where we get the moles. So here's our formula. M1V1 equals M2V2. M stands for concentration, V stands for volume, okay? So the good news is the math really is pretty simple, okay? M1V1 equals M2V2, and this formula is in your reference table, so you don't have to have it memorized, okay? So let's see what an example problem might look like. What volume of 2.00 molar calcium chloride would you use to make 0.5 liters of a 0.3 molar solution of calcium chloride? Okay, so let's list out what we've been given. We're trying to figure out what volume of this we'll need, okay? So here's our original concentration. So M1 is 2.00 molar, okay? V1, we're trying to figure out what volume of that we need, okay? Would you use to make 0.5 liters? There's our new volume of a 0.300 molar solution, okay? There's our new molarity. We're trying to make that, okay? Now it's just a plug and chug. We're going to use our dilution. Our dilution formula. M1 is 2. V1 we're trying to find. M2 is 0.3. And V2 is 0.5. Okay, now let's do a little tiny bit of algebra. How do we get this 2, this V1 all by itself? Yeah, we divide both sides by the 2. Those cancel, and we end up with V1 equals 0.3 times 0.5 divided by 2. When you put that in your calculator, you get 0.075. Don't forget your unit. Okay, let's look at this. Our unit needs to be a volume. Now, it doesn't matter your unit that you put in for V, doesn't matter at all, as long as they are both the same, okay? So you can be in milliliters, you can be in liters here. The most important thing is whatever this unit is, this unit should be the same. So V2 was 0.5 liters. That means this one has to be 0.075 liters. And there's our answer. Let's see if that makes sense, okay? M1 has a concentration of 2. M2 has a concentration of 0.3. Does it make sense that the concentration went down when we added more water? So we're adding more solvent, not adding more solute. Yeah, it would make sense that the second one has a lower concentration. So no matter what, your second concentration, your second solution will always have a lower concentration. But what happened to the volume? It went up. Why? We're adding water. So our second volume should always be higher than our first volume. Second volume was 0.5, first volume was 0.075. So those are two ways that you can check your answers, that you can make sure you're getting the ones matched up and the twos matched up accordingly. Okay, that's it. Now we've learned about dilutions.